Alright, so we had learned quite a few things about invertibility and so on, square matrices and system of equations. Now today we would like to look at what are called determinant of a matrix. Determinant of a square matrix, and then we relate it with invertibility and so on. So what it turns out is that A is singular, there is a notion of singularity and there is a notion of non-singularity. So there is this definition, I will just write it down, whether we have not computed what the determinant is, but I will just write it. So A is n cross n, A is said to be singular if determinant of A is 0 and is said to be non-singular if determinant of A is not equal to 0. So, this non-singularity is equivalent to saying that, so since it is a square matrix we can talk of invertibility. So, A is invertible. So, all these notions of invertibility, having system of equation having a unique solution or system of equation having a solution for every choice of B and so on, they are all related in some sense, all right. So, therefore, we need to understand this, what is called non-singularity of matrix or determinant of a matrix. I would also like you to know that determinant of A is nothing but volume of certain objects. It is nothing but volume of certain object, what is called a parallelepiped, all right, fine. So, for example, when I talk of singularity, basically it means that when I am looking at say a length of a line, all right, fine, length of a line is a meaningful object when I am looking at a one dimensional object, fine. So, if I have the, so if I am looking at the interval, so I have an x axis here and I have the interval say 0 to 2, then length of this line, length of this line is 2, fine. If I am going from here to here, it counts twice. If I am going in the opposite direction, it is minus 2, all right. So, it is 0, minus 1 and things like that, fine. But suppose I have a figure here in R2, we have x and y, fine, and I have 0 to 2 here, but the height here is again 0 itself. So, height is 0 itself. So, in that case we get only one line and I am looking at just this area of this portion. So, area, if I want to talk of area of an object in 2 dimension, but has only the x component or the y component, but has only length or only width, then area is equal to 0, all right, fine. Because we need, for area we need, so even if I am got a parallelogram here, I need, it should have certain height and it should have a base, fine. So, when I say that, so width is nothing but the height that I am talking about here, fine. So, what we need is base as well as height. So, we need 2 components, yeah, same 2 dimension, 2 components. If I am looking at 3 dimensions, for example, a cube, then I have got 3 things, all right. So, if I am looking at a cube, fine, if I am looking at a cube, then I need a base or the length, then I have this which is the width or height, whatever you want to say, depends on you, and then I have a third component which is this part, fine. So, there are three objects that we are looking at, and this I can say it as height, whichever you want to say height depends on you. So, there are three components. So, in 3 dimension there are 3 components. So, in general when I am talking of determinant, say in dimension n, all right, n dimension, then I should have n components, fine. So, we have got n components. So, again what I am trying to say again is that if I am looking at a 3 dimensional object, but there the height is 0, volume will be 0, but the area it still has some area. Similarly, when I am looking at 2 dimensional object, area will be 0, but there will be at least one length, whether the length will be there or there will be a width or something will be there, fine. So, in which dimension you are looking at, that matters. So, singularity basically means that I am looking at something in say 10 dimension, and singularity means that from 10 dimension I am going to 9 dimension or 8 dimension or something like that, fine. So, whenever there is a notion of singularity, it basically means that I have not got full dimension, all right. The object that I am looking at does not represent the object in the full dimension that I am required to look at. That is very important, all right. So, with this notion, with this understanding, let us look at some notations and then proceed to get our definitions, all right. And also I will not give you the actual definition, because actual definition is a bit difficult to understand at this stage, but I will give you some ideas, fine. So, some notations, notation. So, suppose I have got S and T, 2 subsets of, so I am looking at an n cross n matrix. So, I have a set 1 to n, and S and T are subsets of this. So, there is a notion of what is called A of ST like this, fine, as subsets. If S consists of single objects like I and T consists of single object j, then I will write A ST just as A of ij, all right. The important thing here is these brackets are what are called small brackets. So, let us not get confused with the idea of Aij here. This Aij was entry in the intersection of ith row and jth column, all right. But here this means submatrix obtained by removing ith row and jth column. So, there are 2 different things. Here I am removing the things, here I am looking at the corresponding. There is a I comma j and there is a I and then vertical line j, all right. So, these definitions are important. Here it is A S vertical line T, all right. So, I am removing rows corresponding to S. So, this part corresponds to removing rows corresponding to the entries in S and removing columns corresponding to the entries in T. So, let us take an example to understand it better. Suppose I write A as 1, 2, 3, 2, 1, 4, 3, 1, minus 5, I have A. I write B as say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 4, 6. Suppose I have this. So, it is 4 cross 4 here, it is 3 cross 3 here, the square matrices. These definitions can make sense even if it is rectangular. Similarly, you have to take S and T as subsets. But here if I am looking at A of say 2 comma 3, so I am removing the second row So, remove the second row, remove the third column, remove the third column. So, let me, I think I should do it with some other ink, there is a problem otherwise. So, I am looking at this part and this part. So, if I remove this, what I am getting is 1 3 entry here, 2 1 entry here. So, this is my entry, all right. So, I have got removed the second row and third column. If I am removing say 1 2 comma 1 2, all right, then this is equal to, so remove 1 2, remove the first and second row and remove the first and second column. So, if I do that, this goes off, this goes off, this goes off, this goes off, I am left with minus 5 only. Is that okay? Fine. So, this is what you have to be careful about. Similarly, when I am looking at here, I can look at B of 3 4, I am removing the third and fourth. So, I am doing that third and fourth, it is, and this is the fourth one. So, it is 1 2 3 5 6 7 1 2 4. Is that okay? So, you can remove and then you can look at what is left out and things like that. Fine. So, with these notations, let me now define what is a determinant of a matrix. So, determinant, so A is n cross n. Determinant of A is A itself if A is 1 cross 1 with A as just A, all right, it is 1 cross 1, fine. And for the general setup, it is, so I have got A as Aij, fine, j equal to 1 to n, n cross n. There is a notion of what is, all right, so let me write first. So, j plus 1, A, so I am looking at 1 here, 1 j, all right. So, j will go from 1 to n. So, A11, A12, A13 and so on, and then I remove the corresponding 1 is the first row. So, I remove the first row and j for the jth column. Is that okay? So, what basically what I am trying to say here is that if n is 3, I am looking at determinant of A as A11, I should have written determinant here, A of 1j into determinant of A of 1 plus 1 is, so let me write that also 1 plus 1 plus minus 1 to the power 2 plus 1 A12 into determinant of A of 1 2 plus minus 1 to the power 3 plus 1 A13 into determinant of A of 13. So, which is same as A11. So, what is determinant of this? It is nothing but, so I will write like this. So, A11 remove the first and second. So, it is A22, A23, A32, A33. So, this vertical line means determinant. Vertical line means computing determinant, fine. This minus 1 here A12 times remove the first row and second column. So, first row, so A2 and second also. So, what should I do? So, let me write it so that there is no confusion here. A11, A12, A13, A21, A22, A23, A31, A32, A33. This is the matrix that we are looking at. So, I am supposed to remove 1 and 2. So, I am supposed to remove the first row and second column, fine. So, I am left out with this part A21, A31, So, I am left out with A21 and A23, A21, A23, similarly A31 and A33 plus A13 into, now I am supposed to remove the first row and third column. So, now I am supposed to remove this column and this row. So, this goes off, I am left out with this part, all right. So, I am left out with A21, A22, A31 and A32. So, this is again A11. Now, I can again apply induction here. So, this is true for if n is greater than equal to 2, fine. N equal to 1, I had already given you the definition, and this was for n greater than equal to 2. A11, again it is A22. Now, from here remove this row first and first. So, it is A33 left out. Again I have to remove this, but now look at here, this is supposed to be the 1-2 entry. Since this is the 1-2 entry, therefore, I need to look at minus 1 to the power 2 plus 1, which is negative. So, minus of A23 into A32 minus A12 into again A21 into A33, A21 into A33 minus A23 into A31 plus A13 into A21, A32 minus A22, A31. So, the important thing here is that this is a formula. So, you just have to remember it the way you compute, fine. There are 6 terms in this. So, that is the more important, there are 6 terms and they come with positive and negative signs, fine. How do I get in general? Question is question. In general, how do we decide the sign, fine, and that is one question. 2, if A is n cross n, how many terms do I have? How many terms? All right. And what are those terms? What terms? Fine. So, we need to understand these things. So, let us go back to the first part. So, if I look at this part, it says that I am looking at this diagonal. So, there is this diagonal that I am looking at. This is the first one, fine. This part is looking at A11, then I am looking at this part, and this gets associated with this one here. This is the second part, fine. Now, when I am looking at this one, fine, it is A12 is coming from here, and then it is looking at A21, A33, A21, A33, fine. Is that okay? That is the way it looks like. It looks quite complicated. So, to make it easy, let me write it in a different way now. All right. So, if I want to proceed, that becomes complicated. So, let me write it differently. So, I will write it like this: A11, A21, A31, A12, A22, A32, A13, A23, A33. Now, I am looking at rows, so I am going to expand it further, write the terms again and again, all right. So, A11, A21, A31, A12, A22 and A32. Let me write all these terms, fine. Then the first one is looking at this one, fine. The second one, we have already seen what was that. Second one was A11 into A32, A23, all right. So, this was there, fine. The next is A12, A21, A33. So, let us look at this 1, 2, then it is 2 1 and 3 3. Is that okay? So, this is what you have to be careful about. How do I get this term here? Fine. Is that okay? So, you can see here that there is a A21 here and A33 is here. Is that okay? Fine. So, A12, look at here, A21, A33. So, there is this green term here. Fine. So, you can use this idea also to get all the terms. Fine. Then you have A12, A23, A31. So, this part, this one is A12, A23, A31. So, A12, A23, A31 is here. Fine. You can also note that this term that I wrote, all right, I could have got it differently also. This I could have got through this diagonal. Fine. So, once I go through this means, so once I need to go in this direction, another I need to go in this direction at each term. Similarly, let us look at here what happens here, the last one, 1 3, all right, 2 1 and 3 2, 1 3, 2 1 and 3 2. I have got something like this. I want a corresponding thing back here. So, I should have written one more term here, it means A13. So, look at A13, A31 and then I have this term here which is this part A13, A31, all right. So, all the 6 terms are there, once going in the direction which is this, the other I am going in this direction, fine. And signs we have to be a bit careful to understand it. So, let me look at some examples to proceed further, all right. So, examples. So, if matrix A is just -1, determinant of A is -1, 2. If A is 1 0 0 1, determinant of A is 1. If A is 2 0 0 5, determinant of A is 10. If A is 0 5 2 0, determinant of A is -10. 3. If A is 1 2 3, 2 1 3, 0 1 4, determinant of A is 1 times 1 3 1 4 minus 2 times 2 0 3 4 plus 3 times 2 0 1 1, which is same as 4 minus 3 minus 2 times 8 plus 3 times 2, which is same as 1 minus 16 plus 6, which is minus 9 I think. So, what you have to do is that you have to calculate yourself, because I do lot of mistakes. Be careful and see that everything is nice. I cannot verify it here whether I have done it correctly or not, but I would like you to verify it yourself whether the calculation is correct or not. Fine. Another example, so that I know I have done correct work. A is 1 2 3, 2 3 1 and 1 2 2. Then determinant of A is 1 times 3 1 2 2 minus 2 times 2 1 1 2 plus 3 times 2 1 3 2, which is same as 6 minus 2 minus 2 times 4 minus 1 plus 3 times 4 minus 3, which is 4 minus 6 plus 3, which is 1. So, this is indeed correct. I do not know whether this is correct or not, please find it out yourself. Is that okay? So, this is the way we compute determinant. So, before I go to the next definition, next idea, what I would like you to see here is that look at this part, all right. What I have done is I have just interchanged rows and columns, fine. So, I have just interchanged, look at here, the columns have been interchanged, columns interchanged, all right, and the determinant gets multiplied by -1. What is more important from my point of view is, look at things here. My vector 2, 0 was, this was my vector say 2, 0, fine, and 0, 5. So, this is 2, 0 vector, this is 0, 5 vector. So, 0, 5 is going to be somewhere here, fine. I am looking at area of this, my vector, this is the first vector, this is my second vector, and I am going in this direction, counterclockwise direction, and it makes sense, and I am getting a rectangle, and its area is 10, that you can compute, that you know yourself. Similarly, if I have a vector here, say 2, 0, I have another vector here, say 2, 2, I go like this, I form a proper something here, fine. So, if I look at here, the height is 2, isn't it? See, look at this part, the height, this vector corresponds to 0, 2. So, if I look at, so my first vector is 2, 0, the second vector is 2, 2, its determinant is 4, which is nothing but the area of the parallelogram, fine. But if I written my vector as 2, 2 and 2, 0, then it will mean that I am starting at this point and going like this, fine. And therefore, if I want to make a parallelogram using these two, I am not getting this parallelogram, but something else. So, I will have to go in the negative direction and then build up the idea, fine. So, either I shift here and make a parallelogram like this, or I go down here and then make a parallelogram here. So, I have to take a negative direction to get a proper parallelogram, and therefore, I get this as -4. This minus is coming because of the direction, or the what is called an orientation issue with the column vectors. So, I am using the word column vectors because initially I had said in the first class itself that all my vectors are column vectors. You can use row vectors, there is no problem, and accordingly the definitions will go on, fine. But what is important is that you are looking at negative sign coming from some sort of orientation issue. Otherwise, it is nothing but the volume, the area itself here, fine. So, here also if you want to look at, you got -9 here in this one. So, there must be issue with the direction. Try to find out yourself where is the issue, whether the third vector is in the positive direction of the plane generated by the first two or not, and things like that, fine. So, that is all for now, all right.